All right. Okay, so from yesterday. Okay, yesterday we did two things. Okay, so yesterday we did two things. So from yesterday. All right. I'm going to Y from yesterday. Okay, yesterday we did quadratic inequality. So yesterday we did quadratic inequalities. But also we start, the inequality with absolute value and inequality with unknown in the denominator, okay? So inequalities with unknown in the denominator. Okay, and we saw that there is a relationship between these two. So if you want to find the answer for this, you're going to be solving quadratic inequalities. Okay? And also yesterday we said that we can do this quadratic inequality in two different ways. Okay, so you can actually solve them analytically, or you can use a graph. You can use a problem. Okay, so we're going to do one example of each one and then move on quickly to this. So example. Okay, so this is what happened yesterday. Yesterday we talked about quadratic inequalities and inequality with unknown in the denominator. That's it. That's all what we did yesterday. All right, so we did things like this. 2x squared minus 3x plus 2 equal 0.
Are we doing inequalities, sir?
Yeah. So less than 0. Okay, less than 0. So we do things like that. I'm gonna copy something that we can factorize. I'm doing a random question, okay, just to show you what we did yesterday. So yesterday we solved expression like this, okay. We solved non-monic and monic. So we have x squared minus 6x plus 9 greater than or equal to 0. Okay, so we do monic and non-monic. And also what we did yesterday was finding the solution for things like this. 1 over x is greater than 7, for example. And for we did things like 3 over x plus 1 is less than or equal to, let's say 2. Okay, so that is that is the sort of thing that we did yesterday, all right? Okay, and I said to you that when you do these things, okay, as we did yesterday, we can use a problem, okay, to find the solution for this. I showed you how to do that yesterday. And then we went into this sort of thing, okay? Do you remember? Okay, that's what we did yesterday, and we're going to continue with this. Okay, but before we continue with this, we're going to do at least, one of these questions, but I'm going to get one that actually can be factorized. Yeah.
Should I do this in my advanced book? Because that's fun.
Extension. Okay. Okay, so you're going to find A good question. And then we're going to just move on. All right, okay, so let's do this question. Okay, so find the solution for three x squared minus 5x plus 2 greater than or equal to 0. Okay, let's say that we want to find the answer for this inequality. Okay, so the first thing that we are going to do is to factorize it. Okay, so we're going to find two numbers that when you times them together equal positive 6, but when you add them together equal negative 5, right? Okay, so can you please do that and tell me what is the factorization of that? So you're going to find the number, and then remember you need to, if you do it in the old-fashioned way, you need to split this into those numbers and then group them in pairs. Okay. All right. Yeah. Okay, so the numbers 6. So -2 and -3. Okay, and then remember that we break up the middle term into these two numbers. So I mean that this can be done as 3x squared minus 2x minus 3x plus 2 greater than or equal to 0. And then we group them, remember? We group them. So I mean that from here, we're going to have x is a factor of 3x minus 2. And in here, you're going to have minus 1 is a factor of 3x minus 2. And that is greater than or equal to 0, right? And then we said that this is the same as if you do x minus 1 and then 3x minus 2 greater than or equal to 0. All right? You okay with this? Okay. And then we said that we're going to solve this. Okay, we're going to find the answer for this. And for a moment, we're going to pretend that this is a normal equation. Okay, so I'm going to continue there. Okay, so for a moment, we're going to just pretend that this is a normal quadratic equation. So we're going to say x minus 1 bracket 3x minus 2 equal to 0. And from here, we're going to have two solutions. So we're going to have x is equal to positive 1, and x is equal to 2 over 3. All right? Okay. And because this is an inequality, so the answer is not a particular number, but it's going to be an infinite number of them. And then we say that we're going to draw a number line, and we're going to put these two numbers. So it's 2/3 and 1 somewhere here. All right. And because this is including the solution, including where the line crosses the x-axis, so I mean that we are allowed to we're allowed to highlight this here.
Shouldn't it be 2/3?
2/3, yes, sorry, 2/3. All right. Okay, and then also we know that this is going to be a concave parabola because this number is positive, so we're going to draw the picture like that through this 2-point. Okay, and then we know that we're looking for the positive solution, so that means that we look for the positive section of this graph, okay, the one that is about the x-axis. Okay, so this is the x-axis, and we're talking about being greater than or equal to 0, so we need to look what is positive. Okay, so we call this negative, we call that positive. Okay, so we're going to have positive here, we're going to have positive, and this is negative. All right? And then from the picture, we can see that positive occur when x is less than or equal to 2/3 or greater than or equal to 1. Right? So therefore, we will say, therefore, x have to be less than or equal to 2/3 or x have to be greater than or equal to positive 1. Right? But then we use that very special notation, remember? Okay, so then we say that x is in this negative infinity 2/3 interval. Okay, so the left hand side can be described like this, but then we use this symbol, union, okay, to put this together with the other side, and the other side is going to be from 1 to positive infinity. Also yesterday we indicate that we're going to be using square bracket for inclusive, and we're going to use using round or normal bracket for exclusive. And we said also that because infinity is not a number, we cannot put a square bracket there. Okay, so and we'll leave it like that. Okay, so I mean that the solution for this inequality is there. All right, so that's what we did yesterday. All right. Okay, so I'm gonna say that we know how to do this. You need more practice, obviously. Okay, so you need to do the question. But now we're going to spend a few more time doing, this inequality with unknown in the denominator. And we said that we have to treat them in a very special way because when you multiply an inequality by a negative number, you know what happened. Okay, so we need to be very, very careful. And also we need to be very careful and make sure that we don't take x and make this undefined. All right, so we need to make sure that the denominator is never equal to 0. Okay, so that's what we're going to continue today. So you're going to get rid of this. Is anyone copying? No? Yeah. Right, okay, so we're going to do some more questions about that stuff. Okay, I already put this chapter in Canvas. So if you go to Canvas, you're going to see this stuff, and it says equation and inequalities.
Where do you find the answers for that?
There, yeah, I put
On
the
the same document?
yeah. No, it's a different document. You say equation, and then underneath say a work solution.
Oh, I didn't find them.
All right, okay. Maybe I didn't publish it. I'm going to check, okay? But, yeah, I'm pretty sure that I do that. Okay, so solve the following inequalities. solve the following inequalities. Number 1, so we're going to start with an easy one. 2 over x is greater than 3, for example. 2, 1 over x plus 2 is less than or equal to 4, 3. Let's say 3 over 2x minus 1 is less than positive 1. All right, let's say that we have these 3 inequalities. Okay, and then we're going to try to solve them in the best possible way. I hope they all worked, because sometimes when I put random equation, we cannot factorize them, but let's hope that they're all good. Okay, so I'm going to say solution for number 1. All right, so this is the inequality number 1. Okay, what we always do when we have fraction is to get rid of them. And that is what we have been doing all the time. So if you have fraction, that is what we really want to do. Okay, and to get rid of the fraction, all what we do all the time is to multiply by the denominator. All right, and if you have more than one fraction, then you find the lowest common denominator, and then you do that. All right. Okay, but the problem that we have in here is that we don't know whether x is a positive number or a negative number. So that means that if you multiply by x, you don't know what to do with this. Okay, because we know that if this is negative, and then if you multiply to make it positive, then you have to switch that around. Okay, but we don't know. We don't know what x. At this point, we don't know the answer for x. Right? One thing that we need to say is that x cannot equal to 0. Okay, whatever the answer is, we know that x cannot equal 0. Okay, because if x equals 0, then you're going to have to divide by 0, and that is undefined. All right, so we cannot get rid of this fraction by multiplying by x. Okay, so we cannot do that. So then how are we going to overcome that problem? Okay, somebody said yesterday that we multiply by x squared. Okay, and that is the solution. So rather than multiply by x, we're going to multiply by x squared, because we know for sure that x squared will be always a positive number. All right? Okay, so we're going to multiply by x squared. I'm going to do all the steps, but later we're going to save some step. So in here we're going to say 2 over x multiplied by x squared greater than 3 multiplied by x squared. Okay, that is good, because we don't need to worry about this inequality in here. Okay, so we know that that won't change anything, and it's all legal. Okay, and then we're going to simplify. We're going to simplify this part. So when you simplify 2 over x multiplied by x squared, the answer is going to be just 2x. Okay, 2x. And then on the other side, you're going to have 3x squared. Okay, so that's good. We don't have that annoying fraction anymore. And then what we're going to do, we're going to put this together. Okay, so, but I'm going to do it in my head, so I hope you can follow me. So I'm going to put this 2x over here. Okay, so we're going to have 3x minus 2x is going to be less than 0. Can you see that? But then I'm going to flip it. Okay, so I'm going to do 3x squared minus 2x is less than 0. Okay, do you understand this? Okay? Okay. And then we're going to take the common factor. Okay, so let's take the common factor, which is x. So we're going to have x, and then 3x minus 2 is less than 0. Okay, and then we're going to go straight to the number line. Can you see that now? It's just a matter of solving a quadratic inequality. Okay. So now we're going to do the number line. And we know that 0 is one solution. So 0 is one solution, and the other one is 2/3. So we got 0 and 2/3. Okay, but at the same time, we know that even that in here, x equals 0 looks like the solution for this equation, for this inequality, but it's not solution for the original one. Can you see that? So that means that we need to exclude 0 from the set, the solution set. So what we're going to do, we're going to do this only, all right? We don't